So this video is on integrated 3, chapter 8, D-Day number 1. So on these first set of problems, what we want to make sure we're paying attention to is the wording. We want to have our answer in standard form, not in the factored form. Now, what we have to remember and think about this with the quadratic formula is in the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So depending on what we get when we are computing this square root, if we get something that is not a perfect square, let's say I get a root 3, root 5, something like that, then I'm going to get two irrational, well, real solutions with a square root in it. One with a plus, one with a minus. If I get a negative here, then when I take the square root of this, I'm going to get an imaginary part here. So I'm going to be getting two complex answers, one with a plus, one with a minus. So when we are working these out, what you have to realize is if I have a 2 plus I also have its conjugate, which is a 2 minus I. We change the sign in front of the I because that's what we would have gotten from the radical, or in front of a radical if I have a square root. So now I'm going to work this out. Now, when I'm doing this, I'm really thinking about what factor these came from. So for example, this -1 would have come from an x plus 1, because x plus 1, a negative one, to make that 0. Now what's basically happening is it's going to be x minus this, x minus a -1. When I'm minusing something, I'm basically taking the opposite. So when I'm doing the 2 plus I, I'm going to think about it like this. What is the opposite of a positive 2 plus I? That's going to be a -2 minus I. Again, really, I'm subtracting this whole quantity, but I'm subtracting the 2 and the I. And here you see it's a -2 and a minus I. Same idea for this one here. So what is the opposite of a positive 2 minus I? A -2 plus I. Because when I minus this amount, this becomes a negative and this becomes a positive. Now I'm going to multiply these out. And when I multiply these out, I am going to multiply these together. I'm just trying to these together first. So when I do that, let's see, I'm going to have a 3 by 3. I am going to have an x, a -2, and a negative I, an x, a -2, and a positive I, and then I'm going to multiply these. So this box, I'm going to get x squared, -2x, negative ix, -2x, positive 4, positive 2i. Here I'm going to get I times x, so ix, -2i. And here I'm going to get a negative I squared. Now, what happens is when I'm doing this, this negative I squared, not negative ix, and this positive ix are going to cancel out. And this positive 2i and this negative 2i are going to cancel out. Now, I need to pay attention to this particular term here, because an I squared, let me just jot it up here. I'll draw it over here. I squared is equal to a negative I. Sorry, a -1. So when I have negative I squared, that's going to be a -1, which is actually going to be a +1. So this -I squared is really a +1. So now when I combine that piece, I am going to end up having so far x plus 1. I still haven't done anything with that. And now x squared minus 4x because of this. And then the 4 and this +1 are going to make a 5. And now I'm going to multiply that out. So I have an x squared minus 4x plus 5 and an x plus 1. So I'm going to get x to the third, -4x squared, +5x, x squared, -4x, and a 5. And when I combine all of that, I have x to the third minus 3x squared plus x plus the 5. And there's my polynomial. On number 2, just like up here where I was talking about the quadratic formula, if I have a square root of something that's not a perfect square, I'm going to have it with a plus and with a minus. So we also get conjugates, just like I did with my i's, same with this radical 3. So if I have a radical 3, I also have a negative radical 3. Now, when I'm doing this, I'm going to have an x minus √3 for my √3. I'm going to do this one next. So for the negative √3, I'm going to have x plus √3. For my 1, I'm going to have an x minus 1. And for my -2, I'm going to have an x plus 2. And I am going to multiply these together and these together. And then I'll combine that. So for the first one, this right here is really a difference of 2 squares. So just a little side note, if I was to have a plus b times a minus b, that is going to be a squared minus b squared, where I square the first term, I square the second term, and I put a minus in between. So if I square this, I get x squared. When I square my √3, I get a 3, and then I have a minus. That is what I get when I multiply x minus √3 times x plus √3. Again, this is a difference of 2 squares. Now this one here, that is really just a diamond. I don't have the top and bottom, I have the sides, okay, because these were my factors. So I had gotten a -1 and I gotten a 2. So what do a -1 and 2 add to? Well, that adds to a +1, and a -1 and 2 multiplies to a -2. This is always our x term, this is our constant. So this is going to end up being x squared plus 1x, or just plain x, minus 2. Okay, this is where I'm getting my 1x, this is where I'm getting my -2. Now I'm going to multiply those together. And when I multiply those together, and remember that's an x squared minus 3, x squared plus x minus 2, I get an x to the fourth, I get an x to the third, -2x squared, -3x squared, -3x, and a +6. And when I combine like terms, I get an x to the fourth. I have a x to the third. My -2x squared and my -3x squared is going to be a -5x squared minus 3x plus 6. And there's my polynomial. On number 3, we're going to be factoring. And this one, when I clean it up, is going to be a difference of two cubes. And the formula for a difference of two cubes, if I had an a cubed minus b cubed, it is equal to a minus b. Basically, I'm taking the cube root of this and the cube root of this. And then I'm squaring this first term here, this a, so I get an a squared. I change the sign, it's going to be a plus because this was a minus. Multiply a and b together, get ab. And square my negative b, which gives me a b squared. That is the formula. Now, what you'll notice is this 4 and 108 are not cubes, but I can take a 4 out. I'm going to factor a 4 out. So I'm going to factor out a 4, and I'm going to get x cubed minus 27 when I do that math. So now I have this x cubed that's a cube, and I have this 27 that's a cube. So I'm going to have 4, and then the cube root of x cubed is x minus the cube root of 27 is 3. So that's my a minus b. Okay, so now I need my a squared plus ab plus b squared. So what I'm going to do, I am going to square my first term. So I get an x, I get an x squared. I'm going to change the sign. So now it's a plus. I'm going to multiply these together. So I get a 3x. And then I'm going to square my negative 3, which is going to be a plus 9. And that is my factored answer. On number 4, this is one that you want to recognize as quadratic in nature. I have a trinomial where I have this being a constant. I have this x squared, and if I square an x squared, I get an x to the 4th. So I'm going to write it as a let u, and then I'm going to undo that. I usually don't write it that way myself personally, but I'm just going to do it for a second. So let u equal u squared. Well, if I squared u squared, if I square u, I get u squared. If I square x squared, I get x to the 4th. So really, I could have rewritten this as u squared minus 8u plus 12 equals 0, and then factor that. Now, the way I think about it is, again, I'm going to leave it in this form. And what I look at is if this can be squared and get this, then it's quadratic in nature. So I am going to think of this just as a plain old diamond. What multiplies to 12 and adds to negative 8, which is really what I'm doing right here also. So that's going to be a negative 6 and a negative 2. Now, it's not an x minus 6x minus 2 because this is not an x. This is an x squared. So I am going to have x squared minus 6, x squared minus 2 equals 0. And I'm going to show two different ways to think about solving this problem. One way is to look at this and go, hey, this really could be written as a difference of two squares because of a square minus 6, which isn't a nice square, but I could take the square root of 6. That would be an x plus root 6 and an x minus root 6. I can do the same thing here with this x squared minus 2. It is a really kind of like a difference of two squares. The square root of x squared is x, and the square root of 2 is a root 2. So an x plus root 2, x minus root 2. Again, this is equal to 0. So then when I solve, this is going to be a negative root 6, a positive root 6, a negative root 2, and a positive root 2. This is one that I could not have used synthetic division because none of these are rational. All of these are irrational answers. And notice I have conjugates, plus and minus, plus and minus. Now, a second way to have done this is some of us may not have noticed that this and this are differences of two squares. And so what some of us might have done is just taken the x squared minus 6, set it equal to 0. Take the x squared minus 2, set that equal to 0. I get x squared is equal to 6. X squared is equal to 2. And then I'm going to square root. And when I square root, I get a positive and negative root 6, where you see I got the same answers here as here. And when I square root of 2, I get a positive or negative root 2. And again, I got the same answers here or here. And a little side note, if it is a degree 4, I should get 4 answers. Whatever the degree is of the polynomial, that's how many solutions or roots you should have. Okay, number 5. So this is another one I'm going to factor. And what I notice here is I have an x to the 4th, an x to the 3rd, and an x squared. So I can definitely factor out an x squared from everything. And I'm left with an x squared plus 4x minus 32 equals 0. Now this is just a normal diamond. So I can figure out what multiplies to a negative 32 and adds to a 4. And that's going to be 8 and a negative 4. So I'm going to have my x squared, and then I'm going to have an x plus 8 and an x minus 4 equals 0. And then I'm going to solve. Now, when I'm solving this here is going to give me x equals 0 when I set that equal to 0. And it's actually a double, okay, because of the x squared. I am going to get x equal negative 8, and I'm going to get x equal 4. So I did get, it looks like I got 3 answers, but it is a degree 4. But notice this one was really 0 twice. This was a double. So I have 0 twice, I have negative 8, and I have 4. 6. So on 6, what we're going to do is on this one, we're going to do synthetic division. I'm going to be looking at my P's and Q's. So this is my Q. So that's a 6. So I'm going to be looking at all factors of that. This is my P, which is a 3. I'll be looking at all factors of that. And our possible rational solutions are going to be all of my factors of 3, which is 1 and 3, over all my factors of 6, my Q, which is 1, 2, 3, and 6. So I'm going to put both of these over each of these denominators. So if I'm putting them over 1, that's when I get just integers, plus or minus 1, plus or minus 3. When I put these over 2, I'm going to get a plus or minus 1/2 and a plus or minus 1/3. I'm sorry, 2/3, because I'm putting it over 3. Sorry, no. Start one more time. So I did 1 over 2, and I'm doing 3 over 2. Yeah, so plus or minus 3/2. Okay, so now I'm putting my 1 and 3 over 3. So 1 over 3 is going to be a 1/3. 3 over 3 is a 1. Already have it. Now I'm going to put them over 6. So 1 over 6 is a 1/6. And then 3 over 6 reduces to a 1/2. Already have it. So again, I put all of them over 1, which were these two. I put them over 2, which gave me these two. I put them over 3, which gave me this one and a repeat. And I put them over 6, and it gave me this one and a repeat. So these are the ones I'm going to try. Now, again, these ones here would be all possible rational solutions. So I'm going to do synthetic division. I'm going to make a table. 6, negative 18, negative 1, 3. And I'm going to try a 1. Now, what I want to notice is that my 0 is 3. I'm 3 above the x-axis at 0. Okay, just kind of keeping that in mind. Okay, I bring down my 6. 1 times 6 is 6. I add it. I get negative 12. Negative 12 times 1 is negative 12. I add it. I get negative 13. Negative 13 times 1 is a negative 13. I add, I get a negative 10. So I do notice right now that I was above and now I'm below the x-axis. So I do have a 0 in between here, between 0 and 1. So there's a 0 between x equals 0 and x equal 1. Now, maybe it's a 1/2. I could try it. Or I can just stick with trying my 3 next. Let's say I try it. Let's see what happens. Bring down my 6. Half of 6 is 3. I add it here. I get a -15. Half of -15. That's looking like that's not going to give me anything nice. I can keep going, but when I take half of 15, I'm going to get a decimal. Looks like I'm going to be having decimals all the way through. So maybe I don't want to do the 1/2. Okay, so maybe I'll keep going and maybe I'll just try my nice numbers because it could have been a 1/3 or 1/6 also. Let's try 1, which we didn't work. Let's try the 3. Okay, try a positive 3. Bring down my 6. This looks a little more promising. 3 times 6 is 18. I add it to -18, I get 0. 0 times 3 is 0. I add it to -1, I get -1. -1 times 3 is -3. I add it, I get 0. So little note again. So here I know there's a 0. I tried 1/2, that didn't work. It could have been maybe 1/3 or 1/6, or it could have been an irrational number that happens to that I could have gotten in between. So you want to not always sit there and focus on getting that 0 because maybe it's not nice. So usually I will try my integers first, my 1, 3, -1, -3. Okay, so I got one of my answers here. So I know right now that x is equal to 3 as a solution. I now have this depressed polynomial x² - 1 equals 0. And now I'm going to solve this. So I'm going to add 1. I'm going to divide by 6. And then when I take the square root of this, I'm going to I get a positive and negative. And when I take the square of a fraction, I take the square to the top, which would be a 1. And I take the square of the bottom, which is a √6. This is not nice. This is irrational. I don't like having a rack on bottom. So we do something called rationalization. I'm going to rationalize it. So I'm going to multiply this √6 by something that will make it not be a radical anymore. So I'm going to multiply it by a √6, top and bottom. And when I do, I'm going to get plus or minus √6 over 6. And these are your other two answers. Now, if I put √6 divided by 6 in my calculator, okay, the square root of 6 divided by 6, I ended up getting, okay, just so you see the approximation, this was about a 0.41. So that would have been between my 0 and 1. 0.41 would have been, that is the 0 that I was trying to find, and I would never have found it because it's irrational. So I would try my integers first, then go back and try maybe my fractions. So one more time, I have x equal 3 as a solution, and I have x equal √6 over 6 and negative √6 over 6. Those are my 3 solutions. On number 7, we're going to do long division. So I'm going to have 3x plus 4 into, and I want to make sure it's in descending order, 6x to the 4th plus 5x cubed, and I'm not missing a term, plus 8x squared minus 2x minus 24. If I was missing any term below the 4th power, I would have put like 0x cubed or 0x squared, or even 0 if it was the constant. So now when I'm doing this, I focus on my 3x and my 6x to the 4th. I'm not trying to do the whole entire problem at one time. So 3x goes into 6x to the 4th, or 3x times what gets me 6x to the 4th? Well, that is going to be a 2x to the 3rd. And notice I wrote my answer over the x cubed because this was an x cubed. Line it up. Now I'm going to multiply this 2x cubed times 6 times 3x, which is a 6x to the 4th, and the 2x cubed times 4, which is an 8x cubed. And then we subtract. So when I subtract, I make everything opposite, negative, negative. And then when I combine, I get a negative 3x cubed. I bring down my next term, which is a positive 8x squared. So again, I'm focused on this. And 3x times a negative 3x squared would have gotten me a negative 3x cubed. Okay, so when I multiply that, I get a negative 3x cubed. And a negative 3x squared times a 4 is a negative 12x squared. I am going to change my sign so that's a plus and that's a plus. So I am going to end up getting 20x squared. Oops, hold on a second. Let's see. I got a negative 3x to the third. I bring down my 8x squared. I multiply this, I get a negative 3x squared, a negative 12x squared. I add it. I get a 20x squared minus 2x. I'm going to bring that down. Let's see. Just double checking my signs. Okay, so that's a 6x cubed, x to the fourth, a 8x cubed. I got a negative 3x cubed, brought this down. Multiplied, I got a negative, here's my problem. I just saw I got a 20, which isn't going to be nice. So let me just backtrack for a second. Right here. This, when I am multiplying 3x times something to get a negative 3x cubed, I apologize, that is a negative x squared. Okay. So now when I multiply it, try one more time, I'm going to get a negative 3x cubed, negative times the positive 4, so a negative 4x squared. And I'm going to change my signs. So plus, plus. When I add that, I get a 12x squared. Bring down my next term, which is a negative 2x. But again, I'm focusing on 3x times what gets me 12x squared. And that's going to be a positive 4x. So when I multiply, I get a positive 12x squared. I get a 16x. And I am going to subtract. And I get a negative 18x. Bring down my negative 24. And then I need to see how many times a 3x goes into a negative 18x, which is going to be a negative 6. So negative 6 times 3x is a negative 18x. Negative 6 times 4 is a negative 24. And then I'm going to subtract. So I change this to a plus and a plus. And when I do that, I get a remainder of 0. So my answer is going to be 2x cubed. Let me make that better. 2x cubed minus x squared plus 4x minus 6. And I don't have any remainder. So that means that this 3x plus 4 is a factor. Okay, number 8. So on 8, we have to be careful. This is not in descending order. So I'm just going to rewrite this as x to the third minus 4x squared. And then these I can actually combine. So that's going to be a negative 4x and then plus 0 because I don't have a constant. Then I'm looking at this x plus 2 and I ask myself, okay, what makes that 0? And that's going to be a negative 2. So that's the number that's going to go in the little box. And I'll have my constants 1, I'm sorry, my coefficients 1, negative 4, and 0. Bring this down 1. 1 times negative 2 is negative 2. I add, I get a negative 6. Negative 6 times negative 6 is a 12. I add, I get an 8. 8 times negative 2 is a negative 16. I add, I get a negative 16. Now this right here is going to be our remainder. So when I start with degree 3 and I do one thing of synthetic division, this is now going to be a degree 2, 1 degree less. So this is x squared minus 6x plus 8, x squared minus 6x plus 8, and then this is minus 16 over 3x plus 4. And that's our answer. Now on 9, what makes this 0 is a -2. So I'm going to put a -2 here. I have a 1, I have a 0x squared, a 0x, and an 8. Bring down my 1. 1 times -2 is -2. I add it, I get -2. -2 times -2 is 4. I add it, I get 4. 4 times a -2 is a -8. I add it, I get 0. So my answer is going to be x squared minus 2x plus 4. Now, kind of a side note, if I was asked if this is a factor, we would say yes, because I have a remainder of 0. And here, this x plus 2 times x squared minus 2x plus 4 would be what I would get if I factored this using the difference of 2 cubes formula. Okay. Okay. On number 10. So in this case, my Q is a 1, my P is a 20. Since my Q is a 1, my P over Q's are actually going to be integers. So I'm going to get things that multiply 20, positive and negative 1, 2, 4, 5, 10, and 20. So let's see. I am going to do a table again for this. And I've got 1, 9, 1, 9, 24, and a 20. Now, I noticed that all of these are positives here. So if I use any of my positives, positive 1, 2, 4, 5, 10, and 20, when I multiply, bring down my 1 and multiply it with a positive and add it, I'm going to keep getting positives. Nothing's going to cancel out. I'm not going to get a 0. So if you have all positives to start with, none of my positives are going to work. So all of those are eliminated. So now I'm really only going to deal with -1, -2, -4, -5, -10, -20. Also paying attention to my 0, I'm up at 20. Okay, that sometimes can be helpful. So I'm going to start with, let's say -1, bring it down. 1 times -1, I add it to this, I get 8. 8 times -1 is -8, I add it, I get a 16. 16 times -1 is a -16, I add it, I get 4. So I'm going down. Let's try -2 this time. Okay, so every time I bring that lead coefficient down, so 1 times -2, I add it to 9, I get a 7. 7 times -2 is a -14, I add it, I get a 10. 10 times -2 is a -20, I add it, I get a 0. So I found a 0. Okay, so one of my zeros is x equal -2. Now I have x squared plus 7x plus 10 equals 0. So a couple things to focus. This is a degree 3. I should get 3 answers. I have 1. Also, since this is degree 3, when I get this solution, this depressed polynomial is now 1 degree less, so it's an x squared. And I can solve this. I can factor this. What multiplies to 10 and adds to 7? Well, that's going to be an x plus 5 and an x plus 2. So I get x is equal to -5. And I actually ended up with a -2 again. So let me just write out my final answers. So I have x equal -2, which happened to be a double. And I have x is equal to -5. Those are my solutions. And it looks like 2, but really it's 3 because this is a double. 11. So this one's a degree 4. I should be getting 4 answers. And I'm going to have to do synthetic division once to get it down to degree 3, and then again to get it down to degree 2. But my Q is a 1, which makes these be all integers that I'm going to be dealing with. My P is 9. So that means my P over Qs are going to be plus or minus 1, 3, and 9. Now I notice that these are all positives. So really, I can eliminate all the negatives, all the positives, and just deal with the negatives. So I am going to have 1, 6, 10, 6, 9. And again, since these are all positives, bringing down a positive 1 times it by a positive and adding it, nothing's going to cancel out. So I'm going to focus on -1, -3, -9. Also paying attention to it being 0 is a 9. Okay, I'm going to bring down my 1. And when I bring that down, 1 times -1 is -1. I add it, I get a 5. 5 times -1 is -5. I add it, I get 5. 5 times -1 is a -5. I add it to 6, I get 1. 1 times -1 is a -1. I add it, I get 8. Okay, going the right direction. -3, bring down the 1. 1 times -3 is -3. I add it to 6, I get 3. 3 times -3 is a -9. I add it to 10, I get 1. 1 times -3 is a -3. I add it to 6, I get 3. 3 times -3 is a -9. I add it to 9, I get 0. So at this point, this is telling me that one answer is going to be x equal -3. And I now have a depressed polynomial, 1, 3, 1, 3, that I'm going to continue doing synthetic division. I'm not going to try my positives because, again, if they didn't work at the beginning, they're not going to work now. And these are all positives anyways. -1 didn't work before. It's not going to work now. I'm going to try -3 because sometimes you can get a double. And looking at these numbers, I'm thinking -3 might work. So I'm going to bring down 1. 1 times -3 is -3. I add it to 3, I get 0. 0 times -3 is 0. I add it to 1, I get 1. 1 times -3 is -3. I add it to 3, I get 0. So now I have another 0, another -3. And what started as a degree 4, okay, this was my degree 4, came down to a degree 3. When I took my degree 3, now this is going to be down to a degree 2. So I can solve this. This is going to be x squared plus 1 equals 0. And I'm going to -1. And then when I take the square root, I'm going to get a positive and negative. And when I take the square root of a negative, I get I. So I have x is equal to plus or minus I. So if I kind of summarize my answer, okay, I had x equal -3, which is a double. So those are 2 answers. And I have x equal plus or minus I, which are my complex conjugates. So those are my 4 answers. On number 12, I'm going to ignore the y-axis labeling and just focus on the x, because I'm not going to be paying attention to how high or low I'm going. So when I'm doing this, I need to find my zeros, my roots. So I'm going to have 0, -4. And when I take 2x minus 7 and set it equal to 0, I'm going to add 7 and divide by 2. So I get a 3.5 or 7/2. So I am going to come to, let me get my cursor. I am going to come to 0, -4, and 3.5. Now, this is a degree 3 polynomial, and it is a positive degree 3. So it's a positive degree 3. And a positive degree 3 is like all odds. Think of it as an increasing line. So I'm going to be starting below and ending above. So my end behaviors, that's my end behaviors. Okay. Going down to the left and up to the right. So I'm going to start down here. And I don't care how high it goes. I'm not really going to be grading you on that. I want the zeros. I want how they are affected here on the x-axis. And each of these is single roots, so they go through. Okay, number 13, similar idea. Now on this one, I have a 0. I have a 3, which is a double. And then I have a 1. This is going to be 1, 2, 3, 4. This is degree 4, and this is going to be a negative degree 4. And all evens, I think of parabola. So this is going to be like a negative parabola, like an upside down parabola. So my end behaviors are down, down. Both sides I'm going to be going down. So now when I'm plotting this, I go to 0. That's a single. 3 is going to be a double, and then -1. So I'm just going to, my double is 3. So I'm just going to kind of highlight that just so I focus on being careful there. Okay. So since this is a negative even, I'm going to be starting below. And I'm going to come and go through, and then here, since it's a double, it bounces off. Okay, on 14. So here we're going to write a possible polynomial for a graph that passes through this point, okay, 1, 27. And we have these x-intercepts. So I'm going to have an x plus 2 because of the -2. I'm going to have an x minus 2 because of the positive 2, and an x minus 4. So I'm going to have y equal a. Now to find my a, I'm going to put that point in, that 1, 27. So I'm going to have 27 is equal to a times 1 plus 2 times 1 minus 2 times 1 minus 4. So 27 is equal to, and here I'm going to have a times 3 times -1 times -3. So -3 times -1 times 3, that's going to be a positive 9. So I'm going to have 9a. And then when I divide by by 9, I get 27 over 9, which is going to be a 3. So my equation is going to be y equal 3 times x plus 2 times x minus 2 times x minus 4. They're not asking for it to be in standard form. So, but I do need to be finding an a because they gave us a point for it to go through. And so that's my answer. On 15, when we have a problem like this, where we have x to a power, we want to isolate that. So I'm going to divide by 3. I get x to the 4th is equal to 16. So then I'm going to take the square root, well, 4th root, I apologize. So when I take the 4th root, anytime I take an even root, I always get a positive and negative. And so when I take the 4th root of 16, the 4th root of 16 is actually nice. It is a 2. So my answers are plus or minus 2. Those are my answers. And you might say, well, we need to have 4 of them. I have a positive 2 twice and a negative 2 twice is what's going to happen. Because if I was to rewrite this and I thought of it in this type of a form, this would be a difference of 2 squares, and I'd have x squared plus 4, x squared minus 4. And actually, wait, I'm going to get some imaginary answers here too. Sorry. So when I'm doing this, that's going to be my positives, but I am going to get imaginary. So I'm going to end up with x plus 2i well, let me do this. X plus 2i, x minus 2i, but let me just set these factors to 0. So when I set this to 0, I'm going to have x squared plus 4 equals 0, which means x squared equals a negative 4. So x is going to be plus or minus 2i. Okay, that's 2 of my answers. This here is going to be what I got when I solved it the other way. So that's going to be x squared equals a positive 4, and that's going to give me my positive and negative 2. So I do want to make sure I factor it in this form, or I'm going to lose my imaginary. This is only going to give me my real solution. So these are my 4 solutions. On 16, when I have a logarithm, I want to rewrite it in exponential form. So my base is 4. My log always equals my power, so this is my power. Okay, so that's going to be the 3 here, is equal to 3x minus 1, and now we're going to solve. Now 4 to the third is a 64, is equal to 3x minus 1. 65 is equal to 3x. I divide 65 by 3, and I get 65 over 3, or a 21.6 repeating. Let me try it again. A 21.6 repeating as our answer. Now, you always want to check to make sure that you're not taking log of a negative or 0. But if I put a 21 point something here and times it by 3 and minus 1, I'm not going to get 0 or a negative. So this answer is good. But you do always want to check. On 17, I'm going to divide by 3 to get my 2 to the power x by itself. So I get a 15. Now there's 2 ways to think about this problem. One way is to log both sides. And so if I'm doing that, I would take log of 2 to the x equals log of 15. And since I'm not writing a base, it's base 10. When I take log of something to a power, this power moves in front. Properties of logarithms, so this would be x log 2 equal log 15. I'm going to divide both sides by log 2. And when I put that into my calculator, log 15 divided by log of 2, I end up with about a 3.91 when I round as my answer. Another way to think about this problem is to take this, which is an exponential form, and write it in logarithmic form, which would be log base 2 of 15 equals x. And we can put that into our calculator, okay, using the alpha y equal button on your calculator. Number 5 will be logs, and I can put log base 2 of 15 in, and I get my 3.91 there as my answer. Same thing, different way of thinking about it. And again, when I did this in terms of using the TI-84, I did alpha and window. And then you get a menu that appears. And when you do that, it's going to be number 5. which says log base, and that's the one I'm going to pick. Okay, 18. Now on 18, I want to make it look like number 16, where it's a single log. So I'm going to be using my properties of logarithms. And so when I have two logs adding together, I can write as a single logarithm. Okay, so log base 10 right now, because there's no base listed, and I multiply the two things I'm taking the log of. So x times 4x is 4x squared is equal to 2. So now at this point, I'm going to rewrite it in exponential form. So my base, since there's no base here, is really base 10. And remember, my log always is equal to my power. So it's going to be 10 squared is equal to 4x squared. So I have 100 is equal to 4x squared. I divide by 4, I get 25 is equal to x squared. Take the square root of this and I get a positive and negative 5. Now again, we always want to check here and here to make sure I'm not taking log of a negative. 5 works in both of them. The negative 5 does not. So my only answer is going to be x equal 5. And that's the end of this video.